Hey everyone, I'm gonna teach you machine learning in this one single video. Yes, you heard it right. This is gonna be the shortest machine learning video ever. But before that, let's do an exercise. Let's say I want some apples. So I go to a market. On day 1, I buy 1 apple. And on day 2, I buy 2 apples. And on day 3, I want apples again and I go to the market. Now guess how many apples I bought on day 3? Did you say 3? How did you know that? Did you notice something? I mean, apart from the fact that I wore the same shirt for the last 3 days, did you notice something else? How did your brain know that I'm gonna go on day 3 and buy 3 apples? Basically, you found a pattern based on my day 1 and day 2 of data that I've given you, applied the same pattern on day 3, and you guessed I'm gonna buy 3 apples on that particular day. I mean, I could have bought the entire apples from the store on day 3, but still you thought I'm gonna buy 3 apples on day 3. And that's how exactly machine learning works. So, how machine learning is different from traditional programming? So, in traditional programming, you explicitly set the rules. If A, this should happen. If B, this should happen. But in machine learning, you don't do that. You just give past data to build machine learning models. The models has the capability to find patterns from the data that you give, and it will automatically set all these rules by itself and use that particular rule to predict what's going to happen in the future. That's the difference between traditional programming and machine learning. Machine learning can be broadly classified into 3 different categories: supervised machine learning, unsupervised learning, and reinforcement learning. So in supervised learning, models are trained from labeled data. So in the apple example I gave, on day 1, I bought 1 apple, and on day 2, I bought 2 apples. The count of apples that I gave you are the labels, and the models are trained using the labels. In unsupervised learning, models are trained from unlabeled data. What do I mean by that? Let me give you an example. Let's say I come to your class, I divide your classmates into 3 groups. What would you do that? Maybe you will divide your classmates using the rank that they got, or maybe their height, or maybe their financial background. It could be anything, right? So all these things are called features, and without any preliminary labeled data, you just classify your classmates using the variables that you have in hand, and that's what is called unsupervised learning. In reinforcement learning, models are learned by getting the feedback from the environment. The same way how your mom would give a nice and tight slap when you do some crazy things in the park in the childhood. Now let's learn some key concepts in machine learning. As you might know by now, data serves as the fundamental for the machine learning. Features are also known as input variables that the model uses for the prediction. And labels are the output variables that the model tries to predict. Training, the process of teaching the model. And finally, testing, the process of evaluating the model that you built to check for its validation. Do you remember the equation y equal to mx plus c? Sounds familiar to you? So that equation comes under an algorithm called linear regression, and there are a lot other commonly used machine learning algorithms out there. And other popular algorithms like logistic regression, decision trees, random forest, support vector machines, and k-means clustering. Generally, machine learning consists of 2 important steps: training the model and testing the model. So what is training the model? Now you give the data that you have to the model and ask the model to find the patterns within the data. That is called training the model. And when you do that, you shouldn't use the 100% of the data that you have to train the model, because you might need the data to understand how good the model has been trained on. So you split the data into 80% and 20% and just use the 80% to train the model that you have. And the remaining 20% can be used to test how good your model has been trained on. Now you might have a question: how do you know how good your machine learning model is? So that's why we have a lot of evaluation metrics to quantitatively get an understanding of how good your machine learning model is. Let me list a few of the evaluation metrics available out there. Few popular evaluation metrics are mean square error, R-square value, precision recall, accuracy, etc. These evaluation metrics will give you an understanding of how good your machine learning predictions are compared to the actual values which are available. So that's it. You are a machine learning expert now. Now go to LinkedIn and apply for that machine learning engineer job. Of course not. I wish that was the case. But I hope this video would have given you a good start for you to learn machine learning. Now subscribe to my channel and check out my other videos where I've given you some free resources for you to learn machine learning. See you there. Bye.